Hey guys, welcome back to AlgoYogi. We are doing linked list series, and our next problem is design linked list. That's the maybe the most important problem, in this whole series. I guess once you can, if you can do this, then you can do any problem, I would say. So I'm gonna directly dive deep into basically implementing the solution because it's really straightforward. We have like these 6 functions that we need to write down. So let's go over the description. I'm not going to read line by line, but I'm just going to tell you what exactly it's asking and try to understand myself as well. So we got to design our linked list implementation, and we have 2 options to do that. One is we could use singly linked list, where we will have our attribute in the constructor would be a value and next well. So that's like the attributes of the list node that we can create. And the list node for doubly linked list will have value, next, and previous pointer. So because in doubly linked list you can go forward from a node and you can go backward to the previous node if it has any, otherwise the none. So I am going to do singly linked list. Really easy to do. If you guys want to do doubly, that's also easy, and maybe like that might take a little more intuition but less code, because for that you wouldn't have to travel to the end for doing addAtTail. But anyway, let's go into building our linked list. First thing first, we gotta have our list node class, which they haven't implemented for us. We got to do it ourselves because it's a design problem. So let me zoom onto the code and adjust a little. All right, yeah, looks pretty good. All right, so we'll have class, let's call it list node, and I'm doing it for singly linked list, so remember that. So, and then we have our constructor, which is we're going to define constructor. That's how you do it. And I will have one parameter passed to it, so that like when I'm creating list node, I could send in a value and that will return me a list node with that value. And so self dot value would be just value, and self dot next would be none for now, because when you're creating a node, then its next pointer would be none. All right, then let's get into our actual implementation. So my linked list, and for you it's your linked list. Anyway, so we're gonna have self dot head. Every linked list has a head. Initially, let's create a list node and give it any value, 0, like, because it's a dummy node that we're creating that will have a reference to the actual head of the linked list. And we will have size, so that we know, because we're going to deal with like these indexes. So then we need to know what's the size of the linked list if we are trying to access some index that's above our size. We got to check the size. We got to keep incrementing the size, and when we are deleting, we got to decrement the size. So we'll have this size pointer that will help us to find and append at indexes that basically the QA tester is asking us. Oh my gosh, I hate those. I shouldn't say it. I love QA testers. They help us design the robust applications without any errors. All right, 0. Then I'm gonna have a get function now. So we need to return the list node at that particular index. So, but we gotta check if index is greater than equals to my self dot size, then I return -1. That was in the description. If you read it, you will know. I didn't read it, but I know because I can see it like right here. Let me zoom out and show you guys. This is right here. or maybe I should code it like that so that we have it side by side. All right, and that's it. So now, you know what, I'm just gonna zoom in so that we have a clear view of the code. So, but now if our index is valid, we're gonna have a current pointer pointing to head.next. I could point it to head, but then I will have to return head.next, because see, our first node is this and size is still 0. This is a dummy node, so I want to start at the actual head, right? So that is head.next. So now I will have my for loop, just I want to reach to that particular node, what I need to return at index. So in range, that's how you write, like if you not really want to use, you don't want to have I in Python, so addIndex, or you're like, you just want to simply iterate to get to that node. So in the range index, and I'm just gonna move my current pointer to current.next, right? So now after this loop, I will reach at that index and I can finally return cur.value, because it's asking us to return the value. So this is done, and I don't, okay, I think this is what we need to do. We're gonna have self.head also. This is how you refer it. I didn't want to have that mistake. All right, this cur is our variable, so we don't have to, it's not a class level variable, it's a our method variable. Our method is class level. Okay, remember that. If something is class level, you gotta refer it by self dot that thing. Right now we gotta add something at at head. So let's create that node. I'm gonna have it using the list node class that we created, and I'm gonna send in the value. So I have this node, and what I want to do here is I want to have node.next to self.head.next. All right, next. And now since this node is pointing to head.next, my head should point to this node, so that it's inserted between the next and head in between. All right, so my self.head next equals to node. All right, I think that is pretty cool. And that's it. And at head, we don't need to check anything, because even if our list is empty, we are still adding it to the head. That's going to the node.next becomes head.next, and self.head.next becomes that particular node that we just created. Now we're going to append it at tail. So let's create the node. All right, gonna create that node, and we want to reach to the last node in our list, but not the null node, or none node in Python, but we just want to reach to the last non-null node, so that we are at a legit node and we set its next pointer to the node we just created. So cur would be self.head, and we're gonna have a while loop. This time we don't know what's the also this is something I forgot. We gotta self.size, we gotta increment the size if we are adding a node, so we gotta increment the size. So while cur.next, if cur.next exists, then I want to increment my cur to cur.next. Finally, I would be at the last node, which is not none. Then I want to have its next pointer pointing to my node, and now I just want to increment my self.next to not next, size. I'm incrementing by 1 also, because I'm adding at tail. All right, That's it. Do we need to do anything with the node? No, its next pointer is already at none, and we just referenced currents next. That was pointing to none initially, now it's pointing to the node. Okay, second last method, add at particular index. Now, if the index is greater than my size, then I can't really add that. So in that case, I will return. So if index is greater than or equal to self.size, then I will return. Otherwise I will reach to that particular index and I will reference its next pointer to that node and that node's next pointer to cur.next because now next would be or we don't have to do it like that. If we switch the order, then also it would work. Let me show you. So cur will be self.head. All right. Oh my god, what did I write? Self.head. Now I want to reach to that particular index, not that particular index, the node before that. So that's why I'm having self.head here, not self.head.x, because head is still the dummy node. We don't consider it. It's just one node before the actual head. So for in range index, I'm gonna keep incrementing my current cur.next. All right, now I'm at that particular node and I want to have node, okay, node.next. I just realized I didn't create the node yet. So let me create the node. Okay, let's make it a little cleaner. All right, now node.next would be cur.next. All right, cur.next. So node.next is cur.next, so that whatever current was pointing to, now node is pointing to, and now my current wanna point its next to the node. So cur.next is node and self.size. So awesome, beautiful, is incremented just like when we were appending at the tail. All right, now the last thing, we don't want to delete again at an index that's greater than size. So let me have this again. So I don't want to delete at an index that's not in my reach, or that's just invalid index they are asking us to delete at. Okay, then I'm gonna do the same thing that we have done here, except the fact that we are not adding any node, we're deleting it, but we need to reach one node before the node that we are about to delete. So we're gonna have self.head, and then we're gonna reach the node before it. And once we have reached there, we're gonna decrement that, and current.next, we wanna point it to cur.next.next, right? Cur.next.next, and we have already checked if it is equal to the size or it's basically greater than it, then we are not like dealing with it. So let me zoom out and try to run it on examples, and I really hope it's working. I must passing the test, but that really doesn't mean working for everything. All right, so okay, we have some error, and that's in the output. The error is coming from here, because so now we are adding at that index. So equal to, if it is equal to that index, like let's say we were adding at something at index 6, then we can, right? We can't add more than that index, I think. So now at that particular index, we could add if it is the last element that we are adding. So right, so I shouldn't have done that. So let's run it again. All right, so let's write. I don't know if we're gonna write the time complexities, or we have already done it. So in most of the cases, like when you're getting the element, that's when adding at head is big of 1, time complexity I mean, and getting is big of n, adding at head is no big of, get is big of n, add at head is big of 1, addAtTail is big of n because we have to traverse the entire thing, addAtIndex is also big of n, deleteAtIndex is big of n, and space is basically big of n as well because we're storing it inside there. And in the design problem, I don't know if they're usually asking it, but for the entire thing, maybe like for methods, yes, definitely write it down. So let's go back to AlgoYogi. We mark this design problem done. See you guys in the next problem. All right, until then, bye bye.